Got it. Hey everyone, it's Andrew Brown, and welcome to the free GenAI Bootcamp. We are on our week 3, counting from 0, and this week is going to be a fun week. It's either going to be fun or it's going to be our week of hell. It really depends on how things go after this live stream, but hopefully it's going to be a good week. But before we get started here, I want to bring up our slides and do our usual reminder that if you are deaf or hearing impaired, the best place to watch this is to live stream this on LinkedIn. I'm going to get my pen tool out here to make it really clear. Live stream is also on LinkedIn, so if you want to go over there, then if you're on YouTube, we'll drop the LinkedIn link in the description. So check it right there. We'll do our best to follow up with videos with providing captioning. We might have a guest instructor today. We'll see. It's just there's some things in flux here today, but if our guest instructor shows up, it'll be really, really fun. Worst case, we'll just hang out with me today. It's totally fine. We don't have Charlotte today. She's a bit busy with family, which is okay. But let's run through our sponsors here as per usual, and then we'll jump into it. So we want to thank our sponsors, Intel. As you know, Intel is being featured. Some of the software we're using is being featured here at the bootcamp. In fact, OPEA is related to Intel. It is technically a Linux Foundation project originally created by Intel, and we're going to do quite a bit of OPA here today. Obviously, AIPCs and OpenVINO are two other options. And I don't know why, but my watch always rings at noon, and I always forget to turn it off here. Wrapping OPA, you are not alone. Well, luckily, I was able to solve the OPA troubleshooting issues I had, and I actually have a very long video that is already released for this week. And it's optional. You don't have to watch it, but if you want to get deep troubleshooting and see how I worked through and solved it, it'll give you like super deep knowledge in OPA, and you'll be able to do anything you need to do with it. But there were some challenges, but now that I know how to do it, it feels like OPA is super, super easy. But we'll continue on here. I got my pen here. It's I need to turn it off here. There we go. We also want to thank Torque. So for those that have yet to do so, if you can, go create your Torque developer profile. We've added a career builder or career guide section in the bootcamp, and I recorded videos, more videos with, I don't know if it was more, but anyway, I've recorded more videos for the career side of it. So I go through Ken Collins's resume, and I talk about optimization before you import it into Torque, and we take a look at Torque, and so that stuff is there as well. There's CodeRabbit, which we have yet to use, but we are going to use it today. And my interest in CodeRabbit was because at the start of the bootcamp, I wanted to see if there was a tool that we could use that would generate out PR summaries, so that way I could use it to review. I wasn't ready to use it just yet, but now I am. And so we're not going to really get to use it in its full capacity, but I would like everyone to get a chance to use it. And at the start of this video, we're going to try out CodeRabbit because I have a branch I need to merge into my main repo. So we'll give that a go. For FAQs, how do I get my Torque developer profile reviewed by Andrew? Submit the form of the week. Andrew will personally review. Possible optimizations you can apply. That sentence doesn't make sense, but the point is that you can tell I wrote it, right? It's not ChatGPT writing these sentences. But the point is that I have a form. If you submit it, I will review your developer profile. And so import your resume and stuff like that, and I'll make some suggestions if there's any optimizations that you can do there. Can I build my own project that is scoped to the business use case to get Red Squad? This was asked in office hours, and the answer is yes. You can build your own custom thing around it. And to quote Bako, who might be a real person or not, it needs to be shockingly awesome around the business use case, right? So if there's something that you want to build, this can make up for any deficits for every single week that you've done. But it's a gamble, right? You can either focus on extending the existing projects that are here or go full off script and deliver something completely crazy. There is buffer time at the end of the bootcamp to try to build something or deliver something or just to catch up. And that comes to how late can you be? Look at our final due date. There's technically a secret final due date, right? Derek is saying Bako isn't real. It's just maybe it's just me with a sock puppet. That'd be really strange. But look at our final due date in the calendar. And then there's a secret final due date, which I'm not going to tell folks about. But the idea is once we issue Red Squad, it is issued, right? If you miss after that, there's no getting into Red Squad, but there is still opportunity to get in as we're being super flexible this bootcamp around, because we are covering something that is very different. I'm trying to get out of pen mode here, as you can see. Just going to erase that there. There we go. Are there other ways to make it a Red Squad? Your community participation can factor into Red Squad. Some people build great things. Some others are great help to others at the expense of their own work, right? And I noticed this throughout my career, is that there are some people that they are so key to a team because they help out everybody that they end up not doing their own work, but they help out everybody else. We do notice these things, okay? And so we are factoring in your activities in Discord and within the Discord and outside of that. I do look for that stuff when making that decision, and we go through like 3 rounds of checking before we issue out Red Squad. So, just consider that. What is this week? It's containers and agents. So it's going to look really, really thin here, but we have OPEA, so build a custom mega service. Agents, build an agent that has its own agency, and CodeRabbit, try and generate a code review via PR. These are the 3 homework assignments, and we got James. James is our surprise guest instructor. Hooray!
Sorry, some technical difficulties there. I'm glad to join you. I've got the emergency headphones on.
For those who don't know, James' current studio is under renovations, and so it was a bit of a challenge, but we did get James, which is really awesome.
I'm in my living room.
You're in your living room. So you'll just have to tell the kids to keep the TV down, but that's okay. But anyway, so this week is containers and agents, and now that James is here, James, you wanna do a quick introduction for our boot campers? Some probably know you from our first boot camp, but for those who have yet to meet you, can you give us a little rundown?
Yeah, sure. My name is James Spurin. I specialize mostly in the cloud native space, so Docker, Kubernetes, containers. I'm a CNCF ambassador. I'm a Docker captain. And again, in that cloud native world, I do heaps of things with the various different projects. So if any of you actually go to KubeCon in particular, a lot of the keynote events, the project updates, I spend a lot of time helping and working on different things. So I'm actually doing this at the moment for London. We've actually got some keynote exhibitions which are going to be going on before the crowds come in, and I'm working with a different team. So yeah, that's kind of my space. And outside of that, my company Dive Into, I train, I create content mostly on Kubernetes, and I have courses on KCNA and Docker and so on, if anybody's interested in that.
And just to help James plug it a little bit more, because it's always hard as a content creator to plug it, but here's James' website. It's diveinto.com, and you can see he's covering the KCNA and other cloud native stuff. James is like extremely better at containers than I am. I just pretend to know containers, where James actually knows what containers are. So strong recommendation for his content. One question I have for you, James, is what do you define as cloud native? Because we had Ken Collins here, and Ken Collins isn't from the Kubernetes world, and so he was defining cloud native as someone that builds on the cloud natively using managed services like AWS, Azure, GCP, things like that. What would you describe cloud native to be?
So that's a great question. It's actually one of the first parts in the KCNA course. And a lot of the time when that question gets asked of what is cloud native, people typically focus on the infrastructure side, and that the architecture is very much an important bit of it. But I actually like to rewind back on that and think of it, so to speak, as many different areas. It's almost more of a philosophical discussion. So, for example, one of the ones I really like looking at is cloud native personas, so to speak. So where you actually have a culture in your work where you're actually operating in a way which can actually build into that. So driving change, driving things like DevOps, automation, efficiency, all of those different things. In terms of the architecture side, and containers in particular, a lot of the time, when you get that question, right? My application is running in a container, so that my application is cloud native. It's one aspect of being cloud native. It's an improvement, but what about other things that you can actually do? Do you have this where you have self-healing? Do you have this where you have automation? How do you react to different events? And KubeCon's a great example. KubeCon actually has that. The name of the event is KubeCon. It was the first CNCF graduated project. Now you've actually, when you go to KubeCon, you see it's actually named KubeCon and Cloud Native Con. And that other bit, the Cloud Native Con, is really, really important because all of these different projects are at that same level as KubeCon in terms of being graduated. So, various things. You've got Prometheus, projects like Cilium, and these all integrate into that cloud native space. And something I did recently, which is really, really interesting, is the CKA, the Certified Kubernetes Administrator. I did the update exam. So this updated on the 18th of February. And this is one of the most sought after exams in the Kubernetes space. And historically, that exam would very much test you on a Kubernetes basis. A lot of it, the core was Kubernetes. I took the beta exam, which went live on the 18th, and it was tremendously hard. It really had me thinking on my feet. But something that they've actually done this time around with this is they brought in more of the cloud native side. So I have to be careful what I actually say here with the NDA, and what I'm stating kind of corresponds to what I posted as my update on it. But it is now a lot more focus on the cloud native aspect, bringing in other projects which are graduated projects, and rather than it being, you troubleshoot Kubernetes or you're just doing things on this, it's that's a great slide. It's bringing these different ones in. So some challenges like installing certain projects or configuring them have become part of that exam. So yes, in a long way round on your question, cloud native now is very much, you can look at it as those different philosophies. From an architecture side, it's bringing in many of these different tools and adapting them in different ways to achieve the best possible outcome.
And so, for a very, very simple way of looking at what cloud native is, and this is not a good description, is if it's Kubernetes, it runs kind of like Kubernetes, then it's probably cloud native. But I think that a lot of people gravitated towards things being Kubernetes early on because it was the mainstay project. But obviously, there's a ton of stuff in here. But I guess it's more like, here's a bunch of projects that work really together in a cohesive way in the same space, if that makes sense. And as you said, those other points, like it's distributed, it can auto restart or self heal and things like that. When I got into cloud, cloud native was a term that the big providers just used in a different way. That I don't know why, but you know what? I found out cloud native actually existed before that term, so I don't know
if
I was trying to roll plug on the big vendors. Sorry.
It still gets used tremendously, and especially you notice again at these events you notice many stores and exhibitions will they have the cloud native flag. Yes, we're doing this. Some of them are, some of them aren't. But just on that note of Kubernetes, when you actually look at that and you reverse out and you look from the 10,000 foot viewpoint, you've got a system there which has actually been designed from the ground up from a Google perspective, and all of those individual aspects, like you look at something simple like deployments, and you've got that cloud native pattern in the actual design of it. So, for example, when you roll out a new container image, deployments can actually do the mechanics behind the scenes where they will they create a new replica set. That new replica set will roll out those images. When it's successfully rolled that out, it will delete the old replica set. And that's just one simple aspect, but across all of the infrastructure, there's a lot of smarts, and there's a lot of things which, if you're a little bit older like me, we used to try and do ourselves and typically didn't do as good a job.
I like when you mentioned cloud native flag, because in my mind I thought, is there like a real flag that I can fly at my tech center church? And then the town would be like, "What is this?" Like, it's like this is the Kubernetes logo. Like, what is that? But
Yeah.
I think that might be fun.
This is brilliant. So where you actually have this the landscape. So typically where I've been referring with Kubernetes, and you have graduated projects, there's actually three main stages you have with the CNCF and get into that graduated level. So the first, it's very hard to see, but if you were to zoom in on some of those ones in that landscape, some of them are gray boxes, and gray boxes are ones which are there were some there. I think you really like VaultDB was one of them, just or Citrix. Citrix is a gray box.
Well, let's look at the databases. You said in here there was VaultDB.
Yeah. Oh, there, bottom row. So yeah, you see where you see that one VaultDB.
Mm-hmm.
That's where you have that gray box in the landscape. That's where something is actually associated with the cloud native space, but not necessarily a CNCF project. So there will be crossover in some shape. Then the three main categories you've got the entry point, which is sandbox. Sandbox is very easy entry. It's typically projects which are early on. As those projects actually become more and more used, then you're maybe that top one, the maturity model.
These I don't recognize, because I recognize sandbox, but I don't recognize these terms, right?
Do this. If you search for cloud native and then put CHASM, CHASM, CHASM.
That is a hard word to spell.
I know. I got a fun. That's it. Cross in the chasm. And scroll down, and you might find that's it. That's the image I was looking for. This is a good one. So this is the project maturity, and what you actually have there. Everything in the CNCF typically comes in at that sandbox level. So then you get your early adopters who are actually using this, picking it up. At this point, this is typically techies who are A, interested in the project, or B, have a problem that gets solved by this project. So projects come into this space. When they then pick up adoption, become more and more used, then you have this, what is known as crossing the chasm. So that's where the big hole is there in the middle. It's actually very difficult. Whilst the sandbox area is very easy to actually come on board, getting into that middle space, which you see there, the early majority, etc., incubation, is a lot more difficult. Well, you can actually see I've phrased this a little bit wrong. You go from the incubation across the chasm to the graduated aspect. But yeah, all of these, if you get a project in the CNCF and you get it into that sandbox state, it's very impressive. If you actually get it into incubation, that's huge. But graduated is massive, and something you can actually do on that landscape on the side, you can filter and you can actually see the I think it's there you go on the left. See, you can actually choose there. So if you pick, nice. Let's see. So quite a lot of ones which are new projects. And then if you try that out and actually do the graduated ones, you'll see you'll have a load of others alongside Kubernetes. So Kubernetes is there under scheduling and orchestration. And then you've got all of the different ones.
So what's interesting is that there's also the Linux, so for those who don't know, there's the cloud native foundation, but above it is its parent company, or I don't know, guardian company, I'm not sure what you want to call it, the Linux Foundation. And so OPEA, which we're kind of focused on in the bootcamp on the, I say cloud native side, but it doesn't necessarily have to be cloud native. Like, it can use Kubernetes, but it doesn't necessarily have to. So maybe the reason it's on the Linux Foundation's product side is because it's not itself does not embody the things that are like a cloud native project, but it enables cloud native projects, if that makes sense. So I'm like, I don't know why, but it's over on the Linux Foundation side, right?
Yeah. So what you actually have there, so the CNCF, the parent company of the CNCF, is the Linux Foundation. The Linux Foundation are responsible for various things, most notably the Linux kernel as well. So that falls under the realm of the Linux Foundation. There's you can actually see it there. So you've got the CNCF, which in turn then manages Kubernetes. It's huge. It's hard sometimes to keep up with all of the different areas that fall under that Linux Foundation space.
Well, I mean, the cloud native it's weird that they list it as a project, because it's really its own giant umbrella of things, right? Where these other ones, I mean, I'm sure they're big projects. Like PyTorch is a big project. The kernel, the Linux kernel is obviously a big project, but this has a ton of tiny boxes in it, which is really interesting.
And something about this as well. This is only the featured ones. Someone reached out to me at one point, and I can't remember the name of it, but I mean, there was another one which is like 3D gaming, which again falls under this Linux Foundation umbrella.
It seems like some of the CNCF projects are being bubbled up here, so it's a bit hard to distinguish at this level.
Yeah.
But yeah, they obviously are. There's a lot of stuff going around there, which is really, really interesting. But yeah, maybe we could take a look a little bit about OPA. So I have some graphs, and I've been working through it. I want to show James, so that we can kind of get an idea, like, together, what is it that we're looking at as two technical people trying to figure out something. So I'm going to go ahead, and I pulled up Lucid Charts, and I'll go over into here, and I did it in my GenAI architecting diagram. I don't have to share with bootcampers yet. One reason is because my previous diagrams were destroyed. And so I'm just being a little bit careful about those there. But I have this model. And bootcampers, can you tell me if anyone's seen this model yet? Can I get a +1 if you have seen this diagram yet, or a +0, or sorry, -1 if you haven't seen it yet? We'll just give a moment for boot campers to fill in some numbers here. It's better if people say -1 because then I know that we're showing them something they haven't seen, but we definitely haven't explained it yet. So -1, no one has seen this yet. Okay, so now my second question to boot campers is a week or two ago, we did OPA, like the most basic components of it, and it was hard. And it wasn't hard because it was complicated. It was hard because there was a lack of documentation. And so some people were able to do it. Some people almost were able to do it. That was me. And then some people, they really put the time in and solved it. So, my question to boot campers that attempted OPA, how hard was it from 0 to 10? 0 being incredibly hard, 10 being super easy. I don't know. I probably should have done the other way, but anyway, 0. So no. Well, too late. I can't change the number. I can't. I'll make too confusing. 0 if it's super hard, or 10 if it was super easy. So 10, like how easy was it? I should say. So we have a 10. We have a 2. We have a 4. We have a 7.
-100.
-100. So I guess my question to you, James, like you're obviously stellar at the cloud native side. How's your AI side?
Yeah, extremely limited at the moment. It's an area I'm studying a little bit at the moment, but yeah.
But you know what? What I'm finding out is there is stuff specific to models, but all the stuff that we already need to know, like working with containers or Kubernetes or stuff like that, it's all the same stuff, right? And it's just application integration. You can build stuff, but a lot of stuff is built for you, and it's more just rigging them up together and having good sense of Linux networking and things like that. And so I'm telling you, you're probably farther along than you think you are. And I kind of need you because I'm not good at containers. so with our two
Let's
heads,
see what we can work out.
We'll work it together, right? So I'm going to just show the code here for a moment. And for those that found, I'm not sure if people are giving 8 as hard or 8 as easy, but I'm going to assume everyone thought it was hard. But we're going to go over to the OPA, OPA GitHub here. And in here we have two repos. There's more than one, but there's 2 that are important. We have GenAI examples and GenAI comps. So comps represent components of a GenAI workload. What is confusing initially is that when you are using these components, you might think like LLM brings in an LLM model, right? You might think, oh, if I use LLM, it deploys an LLM. If I use embeddings, it brings in embeddings. Nope, that's not how it works. But you'd think that. So the way it actually works is when you use a component, these components here are sitting in front of whatever it is that you want to run, right? So let's say you want to run Ollama. Ollama is it's a server to serve up an LLM, just like you have a web server to serve up a website, Nginx or Apache or something. We have TGI from Hugging Face. We have VLLM from some other company. We have Ollama, which is very easy to use for local machines. And so you have to run this yourself in your own Docker Compose file or Kubernetes. And then this thing that you're launching that's actually in the comp is just sitting in front of it. And it's basically just acting as like a gateway or as a wrapper to the reference of what you're utilizing. And so initially I was confused because I was like, oh, I thought these were all the things that actually launched them up. But no, you actually still have to make your own Docker file. And we can see that if we go over to here into the chat Q&A and we go into Docker Compose and we go into Intel CPU, we'll do Xeon. It doesn't matter if we do AIPC or Xeon. We go into the Compose file. What we can see here in this is we have Redis. We have it says data prep Redis. I'm not sure what the difference. So this is an OPA specific one here. Yep. Then we have an embedding service. So that's running an embedder. This one's running Redis. This one is running specifically the OPA retriever, which is just a Redis server. So there are some specific containers specific to OPA. I don't know enough yet to know. Here we have a re-ranking service, which is another text embedding model. That's all it is. Then we have VLM. That's a thing to serve the model. We have we have a backend server. So this is an OPA specific container that is running, but some of them are containers that run there, and some of them are ones that you don't necessarily run. They're open source models that you're just running there. But the thing is that these open source models, you don't want to just use them directly. You want to have something in front of them to work with them, to normalize their inputs, outputs, to put guardrails, to do whatever you want. And so OPA is this big orchestration that sits in front of it, right? And this thing is kind of like our chat Q&A. So GenAI examples, this is basically components put together in existing archetypes so that you can start working with them. And the one they always focus on here is chat Q&A. So chat Q&A, if we go look up for a second here, OPA.dev, and we go to the technical doc, actually it's right there, I think. No, not that one. And I got to make the full diagram for it. I will make the full diagram for it. But if we go here and we go to chat Q&A and we get an overview, it should have a graphic somewhere here. Yeah, we'll look at this one. This is kind of it. Okay, I'm just going to make it a little bit bigger here. So this is the mega service, right? And so what we're looking at, my diagram is a bit similar, but the thing is that we have, see the stuff on the outside, the TI embedding service, TGI, these things here. These are the things that are running in Docker Compose, right? And then on the inside here, this thing's embedding, retriever, re-ranking, TGI service. Those are the microservices, the components that are basically acting as gateways or whatever you want to call it in front of those external ones, if that makes sense. But this chat Q&A has more moving parts. So like first you have a UI web server, which that is being served in a container. Then you have the chat Q&A on port 8888. So I think, is port 888 like a special port in Kubernetes for like ingress for controllers? I'm not sure. Do you know if it is?
No, it's just it's a common port. Typically, in the 8 range, you'll often see things used with that. It's not anything specific.
Okay. So I know I was talking to Ezekiel and he's over at Intel. He's like, oh, you got to use port 8888. It's the important port. And I went, but is it? Because I feel like you could set whatever port you want. So that's why I wanted to ask you, like, if there was some magic number. So I think it's more like they just settle on that number here and you can use whatever number you want, maybe.
Yeah, I mean, from experience, typically most web-based containers in some way, I see them either using 8000, 8080. They're just common friendly ones.
Okay. And so the thing is, like, they have this concept of like the mega service is not just the fact that components are put together, but they distinctly define the mega service being, if we go back over our diagram here, it's two things. The mega service is actually a microservice that is a fast API that has an external endpoint that you can hit.
Okay.
Right. And then also the mega service is the service orchestrator. And all the service orchestrator is, it contains a DAG and it allows you to define the flow of, like, it lets you register these microservices, but also how they flow from one service to another. Because you're basically setting up a workflow. You're saying, go from, like, this is not the exact same app. The idea is, like, we first want to do embeddings, right? And then we want to then go to an LLM and then return our result. But when we look over here, this one's a bit more complex. This one first has data preparation. Yeah, maybe data preparation, sorry, but we have embedding, retrieval, re-ranking, and then it's serving the model. Like, this is the LLM. So it's going through embedding, retrieval, re-ranking, and stuff. So it has 4 steps here, right? This vector database is probably Redis, right? Like we saw there earlier.
And just a quick question. Yeah, that is the ports on all of those. So the 6000, 7000, 8000. Okay.
But I think you're allowed to make whatever port you want, right? Like, yeah. They have default ports, but I was looking at them. I'm thinking, like, it doesn't matter. You can make whatever you want, but I just don't know of anything being standardized. But I think what's being misrepresented in this diagram is the fact that, well, first, because they're being abstract, whether this is Kubernetes or Docker, but to make it really clear, you know, these things all run in a Docker container. Even this runs in a Docker container, and then the mega service itself could run in a Docker container. But just the way it's illustrated makes it confusing. But now that I have it in my head, I'm not sure if it's making sense for James yet, but we will.
No, this is good. And I mean, typically with a good design pattern on all of this, you should be able to have that flexibility on the port side and it run on a default port, or you actually specify that as an environment variable or so that you can have that flexibility. And bind accordingly as you need.
It says, Josh says, you think Intel would want it to use port 8088? I don't get the joke, but if there's a joke, I'd love to hear it. Do you have any strategies when diagramming complex? I mean, maybe it's not complex for you, but like, I feel like there's a lot of moving parts. Do you have any recommendations on how you would go about architecting the diagram to make it really clear?
Not really, to be honest. I mean,
Okay.
this looks pretty good to me.
Okay, good. One thing here in my diagram that's not really good is that here, when we have our microservice, you have to define a handle request. And this is doing data preparation. And so it has something called Docker API protocol, which here we don't necessarily see here, but they call it here for whatever reason. But let's go see if we can kind of step through the code. And as we go through, we'll keep referencing back to the diagram until it starts to make sense. So down below, I actually do have Windsurf open. And I actually have a little bit of homework I have to do first before we can get this working, because I installed CodeRabbit. And CodeRabbit is it's an AI tool that allows you to, when you create PRs, if you don't write your PR, it will write your PR for you as a summary, so the person that's reviewing it can understand what it is. They also happen to be a sponsor. I wasn't trying to slot them in here. It's just that I installed it, and I can't get around it unless I make a PR. So I'm going to show it off.
It sounds really good, though.
Well, you know what?
mean, and especially because most of them end up as typically like one-liners.
So what I'm going to do is I'm going to go over here, and I was actually going to see if boot campers wanted to do it, because then if they send me their PR in homework, I want to see if it's like an easier way for me to review it, because in a real company, you'd be making a PR and someone would want to review it before it gets accepted. I'm not saying that it has to get accepted to merge it in, but here I'm on my Omen King free GenAI Bootcamp, and I'm going to go ahead here and, we got a pull request, update the code to support multi-ASR systems. And that's something I did last week. I think I actually was specifically made this to show off CodeRabbit, but I'm going to go make a new pull request here. And I have some code that I accidentally committed into this repo, this branch that has to get in here. And so I've gone here, and we have multi-ASR, and it's going from Omen King. But notice where it's going. I don't want it to go to the Exam Pro one, so I just will go here and drop it down. Be very careful about this. And so now I'm bringing my multi-ASR into my main. So I'm going to go ahead, and I'm just going to create that pull request. How do I? Able to merge. Where's the? Oh, because there's already a pull request. That's why. So I'm just gonna close this one here quickly. You already kind of got a preview of what it was showing here, but I did add some more code here. But we'll go over to here, and I'll create a new pull request, and I'm going to again select this to be Omen King from main to not main to main, but multi ASR to main. And so I'm going to go ahead and create this pull request. And what it should do is it should generate a summary for me. So it should show up here at some point. Folks, if you don't know how to install this, I got a video in the bootcamp that I backfilled into it. CodeRabbit is free for individuals. CodeRabbit is free for individuals, but when you sign up, you can turn on a 14-day pro plan that gives you additional stuff. But the free one will do summaries, right? I don't think there's a limit on it. So it's going to go.
I've seen this in use. Now that I see the logo there, I have come across this, I think, in the wild.
I think they raised quite a bit of money, but I mean, I could see it like if you had a team of developers and they weren't writing good commits, or you just wanted another version of it, then that could be really useful. And then saying 8088 preceded 80. Oh, you know what? I think I get the joke. It's with the chip, right? Because it's 8088 chip, right? Yes, yeah. You think I would know because I actually have one of these. Well, not this, but I have a derivative of it. So I like IoTs. Like I have a bunch of IoTs on my desk, and I like building microcomputers. And so I should have clued in that was what we were talking about.
Intel watching this right now, like that.
But it does take a little bit of time for this to generate. It's not that slow, I guess, but we'll see here. But yeah, it'll generate out here in a moment. But while it's generating out, let's go take a look at some code and just try to figure out what we're looking at. So I'm going to go over to here to GitHub OPEA examples. let's just take a look if we can look at the chat Q&A. So in the chat Q&A here, all the code here is happening in the chat Q&A.py. So this could actually run its own container. And I think that that's probably what you'd want to do. If you ran this in production, you'd probably want to run this in a container. I'm actually going to confirm that right now and see if that's the case. So if we go over here to Xeon and we go to Compose YAML, I want to see if that's there somewhere here. So we have OPEA data prep. I'm looking for that chat Q&A here. Is it in here? It's right here. Okay, so it's saying chat Q&A Xeon backend server, but this is the actual thing that is running that piece of code, right? And so we're going to go back over to that piece of code for a moment, which is here. And so we're going to take a look at this code. So the first thing is that, not first thing, but there should be a class here called chat Q&A service. Doesn't matter what the class is called. You can call it whatever you want. It just happens to be called that. Probably if you make a service or make a service, you probably want to name it what it is. Is CodeRabbit something similar to Atlantis for Terraform? No, because Atlantis is specifically Derek, Mr. Terraform, if you want to speak up and answer this in the crowd, but Atlantis it's like before GitHub Actions, it was a way to automate GitOps, to do GitOps. But if Mr. Terraform's still here, he can correct us here. Oh yeah, so here's our summary, by the way. I know I'm all over the place, but let's take a look here. And so we have it: enhanced audio generation with support with multiple text-to-speech providers, improved serviceability. So in this code, what I ended up doing is I used ChatGPT to say, hey, can you make it so you can generate voices out in Japanese with AWS, Azure, GCP? Because I only had AWS, and so it wrote the code for me. And then it gave me this diagram. But the other problem is that I also committed my OPEA code in here as well. So it's kind of a dirty commit. So this really should be two separate ones. But what's interesting, it actually shows us a diagram for, well, we have the audio generator, but then we have the other one. That's actually really interesting that it was able to do both. But here we have the OPEA. So we have the user sends a request to our example service. It schedules an initialization here. It goes to the service orchestrator, which goes to the microservice. It comes back, and then it goes to other microservices, and then it returns. And so that kind of is exactly what's happening there. So that's nice that it did that. It has some summaries here down below. The only thing I don't care is that it gives us a poem. So maybe people like that, but you can see it actually has both of them. It talks about the TTS. So it says, I'm coding a rabbit, hopping the night, dodging bugs with a skip and a bite. New TTS voice sings a delightful tone. Microservices orchestrate never alone. With Docker and scripts, our code takes flight, carrots and commits, making everything right. But anyway, that's cool that we get it. And so Derek's saying to us, Atlantis is specifically for Terraform. But it's like a GitOps solution, right, Derek? And so pretty much the first Terraform automation collaboration software along with Terraform Cloud. Okay, so it's a tacos. It's a tacos. For those that know what tacos are, they're really tasty. Anyway, I just wanted, I wasn't really trying to show CodeRabbit. I just wanted to merge this because once you install it, you have to do everything via these, and it's the only way you can work around stuff. So now I'm in my main branch. I'm going to go ahead and do, I think I'm in my main branch, git branch. And I'm going to do a git pull here. And hopefully I don't get conflicts. Please don't give me conflicts. Please don't give me conflicts. And we will, I don't know why Nano's set here. It's very frustrating. Are you a Nano or a Vim, or what do you use for merging your commits?
Oh, I use Vim all the time. Actually, one of my first jobs, I was using, it was like a Nano precursor. I think it was called Pico or something like this at the time. And my boss told me to stop using it, and I didn't. And I came into work, and it was FreeBSD at the time. He had taken off, and essentially he'd done some smarts. I think like BSD used to use the ports collection, and he'd removed it so I couldn't install. And he said to me, he said, if you ever want to be taken seriously in this profession, you need to learn Vim. Well, Vi at the time. Yeah.
Fun fact: my first flavor of Unix was FreeBSD. So
Yeah.
there was a fellow at our computer store that really liked FreeBSD, and so he showed me how. Gave me the handbook, and that's how I learned how to work with Unix and Linux. And by the way, the handbook for FreeBSD is still really, really amazing. So you can definitely do that. The reason James was late was he was stuck in Vim.
That's it. I couldn't exit.
But
Yeah.
anyway, I cannot not use Vim. So I'm
Yeah.
at a point where if I'm typing and I don't have Vim keys, I get kind of flustered.
Do you use Vim bindings in VS Code as well?
Yeah.
Yeah.
Yeah. Anywhere I can use Vim for not in my browser. I've stopped that. That's not efficient. But anywhere where I can, I install it. Sometimes there's conflicts with certain AI tools, so I have to
Right.
turn it off. But with Windsurf, they're not sponsored, by the way. I just really like them. But Windsurf, it works seamlessly with it. So it's one of the AI coding assistants that I can leave on when I decide to use it. But now that my repo is up to date, what I want to do is I want to walk through a little bit of the code of Chat Q&A, and let's see if we can kind of reconstruct it a little bit to get a better sense of it. So anyway, we have our Chat Q&A service up here, right? And the first thing we do is we initialize it. So if I just split the screen here in half for a second, you know what? It might actually be easier to look at the code if I open this up in github.dev. So I just hit period on my keyboard to open up github.dev. I'm all over the place. We'll open this up, and then I can just do kind of a split screen so we can kind of look at the code in two different places at the same time. But yeah, we have the Chat Q&A here, so I'm going to split it, and we'll bring this over here. So I'm going to go all the way down the bottom. If my font's too small, folks, just tell me in the comments there. And so this is the main. And so for this, I think it's like if you were to try to execute a Python script, it would try to execute this, as far as I understand. So we have some args coming in here. We don't care about that. But here we have the Chat Q&A service. So we say we're going to create the Chat Q&A class, right? That's the first thing. And we're going to say what port the mega service starts on. And from our diagram before, I think that was port 88888 is what they wanted to do there. But you can see it's customized. You have some different options if you want to enable these things. We're going to ignore that stuff. What really matters is that it's going to do this. Then it's going to add a remote service, and it's going to start it up. But let's take a look here at the init phase. So if we go to the init phase of this, here, and font is fine, can see well, thanks, excellent. If we go here, what we can see is it creates a service orchestrator. So if we look at our diagram again, I've kind of lost, I got too many windows now. I'm all of a mess. Maybe it was this one. Here we go. I'm going to bring this over here. If we look at, no, that doesn't have a diagram in it either. Let me pull up another one. Maybe it's, here it is. There we go. So, if we look at our diagram here, the service orchestrator, it shows up. They don't even show it here, but it's in this mega service. But if you look at our architecture, it is this thing. So it's defining this component right here. Okay, so we have my chat. So imagine this is just Chat Q&A. And in here we have our service orchestrator, okay, which is here. And it assigns it as the mega service. And then over here, it assigns Chat Q&A endpoint to this thing here. All this thing is I think it's just like a string. So like you can make this whatever you want. But if you wanted your API to be like API hello world, like hello, then this is what the entry endpoint into the mega service would be, right? It would be this. Sorry, yes?
Yeah. And you can see it's interesting there because where it's actually, so you're in the constructor for the Chat Q&A service, it's creating, it's doing that within that Chat Q&A service object. So it's kind of like a sub object, which I think relates back to that diagram. If you go back, we can see, yeah. So you've got the green box as the mega service, and then you've got that sub box in there.
Yeah, and so this mychat.py is really the class. So like whatever our class is, and this is why I wanted to talk through this with James, because then if there's parts that don't make sense, I can quickly make them make sense here, because I made this diagram for me, and it's hard to say if it makes sense for anybody else. We'll just say Chat Q&A. It's not Chat Q&A, obviously, because we're missing some components, but we'll pretend that this is that, and I'm just going to
Yeah.
reword it so it becomes a little bit more clear as we're going through this. So I'll go here, and I'm just going to bring this down a step here, and I'll call this chat Q&A. Chat Q&A. And so the idea, yeah, we have this mega service, but really we've just defined that part there. And then we had a question: how does the services scale in is OPA production ready? Well, the question is, are containers or Kubernetes production ready? Because this stuff is just going to be running in containers, right? And so the main stuff that is running is those things like Ollama, or I'm going to go back here and show my graph here, but it's like these things here, like Ollama or the embedding thing. In fact, they don't recommend to run Ollama. I was just using this as a simple example, but I found out why people might not want to use Ollama as your LLM server. And it's right now, they don't have OTel integrated into it. So like, if you are trying to make sense of what's going on and something's wrong with your thing, it's very hard to tell. Whereas TGI or VLLM does have OTel integrated. But VLLM, it can work with something called Spark Serve, which allows you to distribute it across different loads. So if you just use TGI, it can only scale on one machine. Whereas if you use Spark Serve, it can distribute. Oh, sorry, I was saying Spark Serve. I meant to say it's the competitor to Spark. It's called Ray Serve. I don't know if you've heard of Ray. James, but I think it's for data folks. So it's a bunch of data libraries, but one they have there is called Ray Serve, and so it can distribute compute, specifically LLM stuff. So there's trade-offs there. So you have to make some choices here, but the idea is that when you go into those options, those different configurations for OPA, they're choosing the best things for production for you. So like if we go back over to the GenAI examples here, and we go into the Docker Compose, right? And you choose Intel, and you're choosing CPU. Like, what kind of CPU are you going to use in production? You're probably going to use a Xeon processor, right? There are obviously other processors, and those aren't implemented here just yet. But if you do need to deploy it, and you want to be CPU heavy, right? Then you'd use a Xeon processor. And you go in here and we check the compose, and you can see like it might be using TGI or VLMs, but you can kind of swap that. So you have to have a little bit of knowledge of your choices, but for the most part, they are making pretty sane choices for you. But we'll go back over to here. And so getting back my diagram here. So we've defined our service orchestrator, right? And over here, we've called chat Q&A. So this part's done. Then it goes over to this part, right? So add remote service. So if we scroll here, it's the next function, which is perfect. Here we can see that we're starting to create microservices. So we have an embedding microservice, which an endpoint, it has /embed. We have a retriever microservice, which has a /v1 retriever. We have a re-rank microservice, which has a /re-rank. We have an LLM one, which has a v1 chat completion, which the reason they made it this specific one like this is because when you use LLMs, a lot of them standardize on the OpenAI API. So if you've ever used OpenAI ChatGPT or Bedrock or anything, they all just kind of standardize because ChatGPT was so popular. Like, all right, we're just going to stick with the same endpoints that they have. And so most LLMs that are being served are going to be on V1 chat completions. So that's standardized. Okay, and so we define all these microservices. Each of these microservices inside the code is just a fast API app. And I was surprised. I thought there might have been like more magic happening behind the scenes, but there wasn't. So I went here to OPA comps, right? And if we go into comps here, like where's this microservice thing coming from? So if we go all the way to the top here, we can see that we are importing microservices from comps, okay? And if we go to the comps directory, we have comps, and in here we have cores, and then I believe it's comma, no, it's mega service stuff. And in the mega service stuff, we have microservice. So this is the actual class that's being loaded. I just want people to know that there's no magic here. You can open these files up and read them, and you can make sense of them pretty quickly. And if you look here, okay, like initializes some properties. So like it's initializing some properties that you might utilize. But when I'm going through this, all I see is UV unicorn. And somewhere in here, there's a fast API. So if I go to the top here, it should define, oh, sorry, you know what it is? The way I know it's fast API is because it extends from HTTP. So when I went to this one, then I could see that it's just a fast API. So it's like a really simple fast API app, and it just adds like a few endpoints here. So we go down here, has a health checkpoint, a V1 statistics endpoint. So boot campers, remember like that we use Flask, right? Even in the first boot camp, we used Flask. We built the entire app in Flask. Flask and Fast API are very, very similar, right? And so I just want you to know, like, there's not a lot of code in here. Okay. And the other thing that they have in here that is a little bit different is something called UV unicorn. So UVI server or UV unicorn. I come from the Ruby world. And in the Ruby world, we came up with our own server called Unicorn. And Unicorn was known for being multi-threaded and zero restart and stuff like that and asynchronous. And then the Python community said, hey, can we have that too? And they just ported our code to their thing. So I'm just saying, like, this is where being a Rubyist, people say it's like a dead language, is garbage, whatever. Python copied it, okay? And we got the better one. But I'm not going to get into that. But I'm just saying, like, there's no, like, you look at this and it's no magic here. This is just the actual web server that serves. So Fast API, when we say Fast API is a web server, it is a web server, but it's more a web framework. So the Fast API is the web framework to define routes. And then the actual web server is this Python flavor of Unicorn. But like you can see, there's just a few endpoints. I think there was some maybe some orchestration in here for it's not in this one, but they have in here. This brings in OTel, Open Telemetry. But anyway, we'll go back over to our other file, our microservice here. And so we go through here, and there's not a lot of functions. Like there's just register microservice. And so what this will do is it will add it to the DAG, the diacrylic graph. Are you a big fan of DAGs, James? Do you like the DAG?
This is a new one on me.
Yeah, I know, right? It's just all it means. A DAG, all it means is that it's basically this. It's just an if-else statement to say, like, if A, go to B, if B, go to C. You know what I mean? But it can self-reflect on itself. So it's I guess computer science people would say this is a tree. Do we have any comp sci folks in the comments? What would you call a DAG? Or you know what? Let's go ask.
Do you like DAGs?
Do you like DAGs? Is a DAG a tree algorithm? It doesn't care if I spell it right. It's totally fine. Node tree. There we go. Node tree. It's not a tree. State diagram. So see, it says it's not a tree. I like how it made one for us. That's pretty cool. So let's explain the relationship between a DAG and trees. A tree is, yeah, I guess a tree ends at some point, right? Think of a tree growing or like roots. It probably ends at some point, where this one's self-reflection. So it says it's a graph, but not reverse, diacritic graph. I mean, it's right in the name, right? It's a diacritic graph. It's not a tree. It's a diacritic graph. But must have exactly one root node. Oh, so it's describing the difference. So must exactly have one root node. Each node has exactly one parent. No cycles. All nodes are connected. Can have multiple root nodes. Nodes can have multiple parents, node cycles, whatever. But DAGs are really popular for describing the state machine or the states, like what state you're in and what you transition to for LLMs. There is debate whether DAGs are good or not. I think Llama Index kind of argues this. So like Llama Index is, we didn't really use Llama Index much, but they talk about maintaining state. And so they have some words about DAGs somewhere in here. I'm not sure where it is, but they might have chose a different way to do it. I'm not sure. And LangChain might do it. And so I don't know what the trade-offs are, but my point is that you can use them. You can use them or not use them if you want. DAGs are popular with data engineering pipelines too. That's the only reason why I know what DAGs are, because I made some data courses and I can pretend that I do everything. But anyway, that's what a DAG is. So the point is that the microservice gets added to the DAG, and the DAG is implemented by the service orchestrator. We can even go into our code here and take a look at the service orchestrator. So if I go up a level here, it has it right here, orchestrator. And somewhere here, yeah, it says import DAG, right? So it imports it. And I actually never looked at it, but here's the DAG over here. Here's the DAG. There's nothing complicated here. It's just you have, you can add a node. And you can delete nodes and stuff like that. So it's a very, very non-complicated implementation. So say, yes, Apache Airflow and DBT. So they're giving examples of where DAGs are used. So, we have a DAG implementation here, a very simple one. And then this thing's registering and it's adding it to the service orchestrator. And if we go back over to the orchestrator, we got code in here. So you can see, we put Dantic and other stuff like that. But somewhere in here, if we go on the right-hand side, you can see we have add. So add the service, flow to, schedule, and execute. And we don't ever use this, but really there's only like 3 commands in this entire thing. It's very, very simple. I know the code looks complicated, but you don't need to know all the code. The point is that there's these 3 things. So we're going to jump back over to the code over here, right? And so anyway, the point is that these fast APIs all get spun up. So they're all little apps that are running. And then you have the megaservice.add, which is adding them all. I guess this is actually adding them to the DAG. I guess you could register them the other way. So I'm not sure why it has register microservice. Maybe that's another way to do it. But here you can see that it's adding each of them. And then it just has flow to. So it says, from here to here. So this is actually defining the direction of where things are going, right? So, and I think that the first flow is going to be the embedding, but literally the order that it's in is what it's going to go. So our data is going to come in. It's going to go to embedding first, then the retriever, then the re-rank, and then the LLM, which is defined with the stuff down below. And I believe the entry point is going to be the embeddings because it's the first thing added. Because it doesn't really make clear what's added first. But my point is that because the underlying code is so simple, if you wanted to add additional functionality, you could literally open it up and say, hey, I want something that has a bit more complexity. And you could say, Windsurf, do that. And that's what I mean when I say that this stuff is really simple, once you know all the moving code that is underneath it. But anyway, so we add these 4 services, right? Right here, which is here. And then we start up the chat Q&A. So if we go all the way back up here, there should be some start function somewhere here. That's add remote service. That's without the re-ranker. It's just an alternative. That's another alternative one. And we have handle requests, which is not there. Then we have our start function. So what does the start function do? Now it adds another microservice as a type megaservice. Why they made it also a microservice is beyond me. I think as a distinction, they could have called it megaservice, or they could have called it something else to make it less confusing. But it serves the same purpose as everything else. But in here, we define a microservice that's a megaservice, and we then add a route to the service and handle requests. So if we go back to our diagram here, okay, this is that other service. That's why I call it the microservice megaservice, which does not sound confusing whatsoever. The microservice megaservice. And so these 2 things conceptually make up the megaservice. Okay, and that add to route that we did here, that's this thing right here. So where we did this part here, where we said add route, and then we said self handle request to the post. And this is self endpoint. We can define it whatever we want. We defined it earlier as I defined it in mine as example service. We can call it whatever we want, give it whatever port we want. But what it's going to do is that when an incoming request comes here, so here's a curl to port 8000, it's going to go to this endpoint, right? And it's then going to call this function. And so this is the handle request. This is where a lot of boot campers might have felt pain. Boot campers, if you felt pain from a scale to 1 to 10, or 0 to 10, 0 no pain, 10 to really painful. For those that got to handle request, how much pain did you feel trying to figure out handle request? Every tree is a graph. Not every graph is a tree. A DAG is a graph, but not a tree where there is no cycles. Perfect. I'm so glad we have some comp sci folks here to help me here. I'm terrible at comp sci knowledge, but we have 10. So everyone's saying pain, 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 pain. The reason we felt pain was because for the handle request, I let everyone down a bad path. It's my fault. because I tried to use Windsurf without reading the code, and I just said, go implement it. And it didn't work, so I just kept saying, go implement it until it worked. How many people here also tried to implement the handle request using AI coding system and not reading the code? How many tried just implementing it AI coding system? Give me an I plus, write an I if you tried to implement it using AI coding assistant, and give me an M if you tried to manually implement the handler request. We'll give it a moment here. So we got M, okay, M, okay. And so for me, it did not matter how much I used Windsurf. It just kept spitting out the wrong stuff. And like some of it was right, some of it was wrong. But once I just sat down, I read through all of it, I went, oh, it makes sense. And I also had to dig in the code, because if I did not dig in the code, I would have never been able to debug it. They said, until my Windsurf trial request ran out. James, have you been using any AI coding assistants yet?
I'm a big fan of GPT, but again, I'm a little bit old school in that I'm just going back and forth.
Well, I think the trap that I'm falling into is that sometimes I want to turn my brain off and let it do the work. But then I realized that it would have been the same amount of time if I just walked through the code myself. But I definitely see help in certain areas, and other places some harm, but that's okay.
I use it a lot. So I find I'm often, especially more since we've had this AI space, coding in areas that I'm not that familiar with. So I've done quite a few projects where they've been low-level C, and in those cases, rely on it quite a lot. On the Python side, I still do a lot of that myself.
Well, I think with statically typed languages, there's just so much boilerplate stuff that you have to look up that it takes that pain out of it. But like if I'm writing Ruby, I don't need, like, even Python, right? It's high level, so sometimes it's more in my way, or I wouldn't even notice if it wasn't there because of my proficiency and the flexibility of the language. And I would rather just go to GPT, and so when I need code, I'd say, give me a code example, and then I might manually write it in the way I want it in. But depends on what it is. But like in this boot camp, I took our Python code and I ported it completely over to Go using Windsurf, and it worked. And it was like, I find these tools really, really good for statically typed languages.
I noticed there a few people mentioning Cursor, and at the last KubeCon was running Cloud Native University, and Cursor got mentioned quite a few times there. Have you played much with that?
Yeah, Cursor is I have it, but I generally uninstall it because it takes over my code. Like when I type the word code, I always want VS Code to open it, but then it overtakes it. But Cursor was the first to release an IDE that that was like a fork of VS Code that made the integration experience a lot better, and it had more flexibility of models you could use. I like Windsurf, which was originally made by Codium, and they have a really good talk. There's an AI summit where they talk about the back of their infrastructure and how they implemented it. But the products are very similar. The difference with Windsurf is that there's less configuration. So like if you want Cursor to work really well for you, you have to know how to configure it properly, and it's tedious to configure. There are some UI choices that I do not like in Cursor, whereas like if I have Windsurf down here, right? And so in Windsurf, the whole point is this agent thing here on the right-hand side. And so it has different modes, write and chat. Write means it will actually try to change my code, and chat will just have a conversation with me. And so I can toggle between these two, and I can retain my history. But with Cursor, if you swap between them, they're like treated completely separately. And so that kind of breaks my flow. But I mean, for the most part, they're pretty much the same. It's just like one's marginally different. It comes up to your preference. But I would just say that, yeah, they work really well. But we'll use them a bit here if we get to some code implementation. So anyway, we want to go ahead and say service start, right? And so this will start up the service, which will start up the fast API, which will serve this route that will then pass it to our handle request. Let me say just a moment here. That said, I tried Cursor for a while after listening to Lex, then went back to Visual Studio Code. I think Cursor took a lot of system resources. And yeah, I mean, for me, like, I think what really made me not like Cursor was that when I was trying to type code myself, it was aggressively overwriting my code as I wrote it. And I was just like, can I just turn that feature off? And I couldn't. But when I used Windsurf, I could just use the agent, and it basically did everything, and it never mucked with my code. But again, they're not perfect. They're just tools. So let's go up to this handle request, because this is the thing that was is really complicated, or I mean, it seems like it's complicated. Cursor has a very good is very good and has a good agent mode. So here we're looking at handle request, right? And so this thing is the thing that's going to handle the incoming payload, right? And so in my example, I'll show you what my payload looks like. If I can find it here. Here it is. So this is my payload right here. Okay. It says it's just messages and then the stuff, stream false, model lambda 3.2, max temperature, whatever. Pretty standard template to send to an LLM. This messages format is standardized because of the open API. So many people have adopted it. So pretty much most modern ones use that format. And then everything else that's additional here can be whatever they want it to be. So the idea is that we are going to bring in the request, right? And then here we got the data. And so this is just checking. This brings it as I think a dictionary or something. I'm not sure what the data structure is, but the point is that we have a request, we get it back, we get the JSON back, and we dump it here as maybe a dictionary. It's going to get the key called stream. It's going to get the key called stream. And if there's no value, it's going to set it as true, right? And so in my code, I said, I'm going to set it to false, right? So it should be false, but if it's not, it's going to set it as true. And so then you have this thing called chat completion request. The one thing, like, there's not a lot of boilerplate, but the one part that OPEA adds for boilerplate is standardizing the inputs for the LLM, okay? And so chat completion request, all it's doing is it's taking the data and turning it into an object or a data structure so that it can be used in other places. So if we were to open up this chat completion request, which I believe is in, I think it's in common component. No, it's not here. Let's go back for a second. Prototype, API protocols. And I'm looking for chat completion request. Maybe I'll just type it in, look for chat completion request. Here it is. And so you look here, and it's really just a class that holds some data. So it says, hold the messages in a structure, hold the model. Here's a bunch of different options that you can have, because it's trying to normalize based on different kinds of LLMs or target locations. Okay, but you can see there's nothing really special here. It does have a couple extra functions. So like if you want to add a generation prompt, you can do that, add special tokens, documents, chat template, but really it's just a data structure. Okay, that's pretty much all it is. Probably right. Yeah. So I'm just reading the comments here. So, there's no real magic behind this. I thought there was like more stuff that was happening, but it really is just a container for the data. It's just taking the data and transforming it into an object so that you can easily reference it and say like dot messages and dot stuff, as opposed to treating it as like a lower primitive, like a dictionary. I guess you could extend it and do more processing if you want, but you look at these things, there's barely anything in them. So there's that part. But then there's another part where we have LLM params. So there's stuff that's defined in the API protocol, which are just really dummy classes that hold data. But then if we go over to Proto here and we go into Dockeray, these are dummy classes specifically for Dockeray. I did not know what Dockeray was until yesterday. And I still don't know that much about it, but I know enough about it because I read the one tagline of what it was, and I'll pretend that I know more about it. It says the data structure for multimodal data. So from what I understand is that this library was built so that if you're working with multiple types of ML models, that it will standardize the inputs for them, right? So like that way, if we have an LLM, like we want to input to an LLM, that input's going to be standardized across it, and it just normalizes it, right? And so this is where I say, like, there's no magic in OPEA. It's just using. Oh, by the way, James, when I say OPEA, I'm talking about OPEA, not OPA, which is a cloud native project, and it makes it really confusing. But that's not my choice for naming.
I love OPA.
Which one?
I'm beginning to love this new one, but yes, I'm a big fan of OPEA. I'm actually I'm in progress working with Charlie, so Charlie's doing the video for that one for KubeCon, so it's it's kind of a parallel at the moment.
Well, if we could work in OPA with OPEA, that'd be really interesting. So I mean, this would probably be interesting to read a little bit more about so we can understand it. But let's take a look here and say, in essence, I've never looked at this part of the code, but Docker Array facilitates data representation in a way that mirrors a Python data class, which machine learning being being an integral part of it, right? So here we have Docker Array. We define our data model, and that's all that that other class is doing, defining data models. And then it goes import from doc vector Docker Array, and then we pass it our instance of our class into a doc vector, and then it does this, and we have this. So it's doing something. Okay, it's doing something. We'll oh, Derek, you're mean. Oh, OPA is the worst. Yes. OPA.
He's been at war with it recently.
Oh, has he?
I've seen too many messages from Derek and OPA.
Well, I mean, I think what, Derek, what's the, we're not talking about OPA, we're talking about OPA, folks. OPA is see if we get it here. OPA, open.
Put CNCF on it. Yeah, open policy.
Oh, that, yeah. Similar name, but OPA is a policy-based control for cloud-native environments. So it's a DSL. So you'll see a video that Derek and George are in, and it actually mentions OPA. But OPA is like this DSL, domain-specific language that allows you to validate the, like, was it like guardrails, or it's a policy? It's policy. It's like to make sure you have conformance of what you expect your configuration to be, is the best way I could describe it. Maybe pronounce OPA. So OPA. Okay, listen. I was calling it OPA originally because I'm dyslexic and I just kind of drop letters, right? But then Derek, who's here, was saying, "Were you talking about OPA, like OPA?" Because he calls it OPA, right? I said, no. I'm talking about OPEA, right? And so I was saying OPEA, and then someone at Intel was like, "That's not how it's called. It's called OPA." And I'm like, okay. So my original wrong pronunciation was correct, but if I call it OPA, it can confuse cloud native folks. And anyway.
So I think, yeah, I'm not too sure how Derek was using it. Where I know it is as an admission controller in Kubernetes. So essentially you can bolt this on, and if you attempted to deploy a pod or a deployment which, for example, didn't have a specific security setting on it, it would reject it at points. So as an admission control, it's very good. I think Derek was doing something quite different. I think you were doing something on a low level with it, Derek, maybe in the comments.
Well, all I know is that OPA can be hard to write if you're not familiar with it. It requires a little bit of investment figuring it out. It says I use a lot of GitOps pipelines for the Terraform IAC. Yeah.
Right.
But anyway, we'll come back over to the code here, wherever it was. And so LM params is just a class that is defined over here. So if we go into Docker Array and we look for LLM ops, it's kind of one of them. There it is. You can see it's just like model max tokens, top K, top P, whatever, right? And so then it's doing whatever this is. Like it's doing whatever it is. I'd have to read more about this, what it's doing. But clearly there's a bit of standardization underneath with it. I wonder if it uses Pydantic in some way. It says coming from Pydantic, but I wonder if it uses that at all to validate the inputs. But when we go back to the original diagram that was over here, this one here, when it says data preparation, I think that's what it's talking about. It's talking about the request handler and how it's putting things into data classes, and it might be using Docker Array to kind of format it into a way that it works there. Does the embedding model, does that use the embedding model underneath? I need a few more words there, but the song OPEA OPEA. Yeah, exactly. But I would say that yeah, we need a little bit more information about the embedding model, but we're going to step through here, and we might answer this here in just a second. So we'll go back over to here, right? And so that's what's happening here. And same thing with the retriever parameters, same thing with this one, just making objects. The magic happens with the schedule function. So we do mega service.schedule. All this is doing is it's starting the process of, I said schedule, but really it's executing the first step in the process. It's passing it to the embedding model. Because remember earlier we said we added it and embedding was first, and then we said flow to. So this is kicking off the process. And again, we look at the code for here in the cores into the proto. Not there, sorry. It was in the mega. And we go into Orchestrator, right? On the right-hand side, we can see schedule. Okay. And if we look at the schedule, you can see it's getting the DAG. It's making a deep copy of the DAG. And then we have async create task. That's for, it's creating asynchronous task. And then it's calling execute, right? And so here it's doing that. And so I guess the thing is that it's just executing the first step of the graph. So whatever, like when you add those things to the DAG, they're getting inserted there. And so whatever's in the start of the DAG, I think is getting executed based on that runtime graph. And so then it does a bunch of other stuff that I don't really care to know right now. Okay, but it does something. And so that code, if I wanted to step through, I could figure it out, but it actually returns back the runtime graph. And so we can actually see what structure is expected. And so here we have the runtime graph that comes back, and we provide its initial inputs. And then down below here, we get a response. But the thing that made it super easy for me to figure out was when I had a problem, my biggest problem was that when I was trying to run my model in this handle request, I just kept getting bad, like obscure errors back from the LLM. I didn't know if it was reaching the LLM. So if we go back over to the this graph here, right? I was trying to, mine's simpler. I don't even have the embedding model, but it would just go from here to this one right away. And then it would talk here. And so where I was having a problem was in between here. I could not tell what was going on here because I would get some obscure error, right? You have to figure out like where your pain point is. But here, I would get an obscure error back and I didn't know why. Okay. And it had to do with like the fact that Ollama has very limited debugging on this side. So like I went to Ollama, and this is where if I had spun it up, I'd be like, hey, James, how do you debug it? But like I went here and I checked the logs. The logs are really simple. If I went into the Ollama container, I didn't have much information. It didn't have OTel. I just had kind of obscure errors that were coming back. And so I had to think, okay, what's wrong with this? It has to be the format of the input. And that's why I had to learn about what was being passed in and how is it passing in here? Because if I could observe at this point here what the payload looked like that was being received by Ollama, I might have a sense of what was going on. But I didn't, because I didn't know what kind of transformation was happening to the model as it was en route to this thing. So I actually, you'll be proud of me, James. I actually used Jaeger. I didn't even know I could get Jaeger to run it and to actually observe tracing, but I did it.
Wow.
Yeah. But I still don't know how to read traces. So, do you, I think you're supposed to see like payloads and traces, right? Or maybe you have to actually set the data to show it that it'll be in the thing, but I don't know. So that might be, I don't know if we'll run out of time here, but if I get to show it, then that'd be fun to peek at. But anyway, this is where my problem was between here and here, right? And so I just had to keep breaking it down and saying, okay, what's actually being passed along? Because maybe there's some kind of magic that's happening within Service Orchestrator. And so I had to go back to the code, and I went into where's our little friend here? It is we're in comps, and we got to go back into common, or do we have it over here? 1 second. Is it over here still? Yeah, the orchestrator. So I said in the orchestrator, something magical must be happening at the schedule, because the schedule is bringing in these initial inputs and doing something here. And so I just carefully looked at the code here and said, okay, what is actually passing things to that microservice? Like, what is it doing? And so I was carefully looking through this. And eventually I found it. I think it was under execute. But if we go, like, obviously execute must be the thing that actually executes to the service to pass to it. And so I skipped over to the execute function here on the right-hand side, left-hand side, wherever it is here. Here it is. And then I carefully looked at here, right? So careful, careful, careful. And boom, found it. Okay. As soon as I saw this, I knew this was the thing that does it, because request.post is the most low-level way that you can send something in Python. It's going to send a post. And so this is exactly what it's doing to the data. Nothing. It literally takes the payload, whatever you pass in that stuff, it just dumps it as JSON and passes it along. Right. And so the huge value here, if Tony's listening, Tony, this is the big, Tony loves troubleshooting stuff that I find here. This is the big golden moment. And you'll see that if you watch that 2.5 hour video, this is the moment that we built up to. But here, we're passing the initial information here. So this, whatever this is, just dump it to JSON in here. You just go here and say, print JSON.dumps, whatever this is. And that's what the payload is, right? And so then all I had to do was go, okay, what payload does it expect to be, right? So all I did is I went back to our diagram over here. Where was it? This one here. And this one's running on a port 9009 or whatever. And so, I can, from my host machine, just hit this port with the right data structure, which I did. So if I go over to my Windsurf code here for a second, and I go into where I was working on this, the mega service, I made a bin here. I have Olama test. This is directly skipping OPEA, and I said, go to this directly. This one says 9009. My documentation is probably wrong, but 9000 is actually the port it runs on. And so this is the structure. This structure, if this was being passed in, this is what it needed, right? And so here at this exact point, I made sure that that was the input that was happening there, right? So if I go back over to here, I made sure that that was exactly the same as that. And then all of a sudden, everything worked. And it all clicked. I went, oh, I get it now. There's no magic happening whatsoever. But because you think that there's magic happening and there's no docs around it, you have to dig around it. But what I was surprised was Windsurf didn't figure that out or help me with that. It was like, it wasn't going deep like I was going. It was just superficially giving me code and going, maybe this will work, maybe that will work. And I'm like, buddy, this stuff isn't working. It just kept working in circles because it can't do that kind of digging like a human can. It's not going to do that. But there's that. But these LM parameters actually kind of get merged in that request. So it's a little bit different, but after that, it was very clear. Here, it came back the results. So whatever it would normally come back with, then I just stepped through and I said, okay, iterate through the document. If it's a streaming document, return it right away. I never figured out how to do streaming. Boot campers, did anyone solve streaming? Give me a plus 100 bonus if you figured out how to get streaming working with this. I'm just curious, did anyone get streaming to work? Or if you didn't, just give us a big N. Or if you folks are sleeping, give me a big S. There's an N. There we go. Okay. There we go. And so, yeah, streaming's hard. It's not hard, but I have to think about it more. But at the end of the day, we wanted to Sanctuary sleeping. There has to be a way to do it. But to me, this was the hardest part, right? Was this thing and not knowing that part of the code. But once I figured it out, all this was pretty clear. Like the runtime graph is just the representation of the DAG. And you kind of see what's coming next. An N plus an N minus an S. Oh, didn't get it and was sleeping. That's awesome. And so I think this chat completion response choices, this is just here because ChatGPT can return multiple choices back. And so this is kind of just a choices filter and then returns back the final thing. And so in that long video, 2.5 hours, I'll show you how to do it. But now that we got 30 minutes, let's do something crazy. Let's see if we can just build a mega service from scratch now that we have this new knowledge. Okay. So I'm going to go over to Windsurf. And I already have the code here. I've already done it once. But let's see if we can build it together in a streamlined way. Because if I can do this in 30 minutes or 20 minutes, then you folks don't have to watch a 2.5-hour video. But if I can't, then you're going to be watching that 2.5-hour video, or you're just going to be copy pasting my code and going, okay, I think I got it, but I don't. So I'm going to go here and make a new folder here. I'm going to call this mega service new. Okay. And in here, we're going to make a new file. I'm going to call this one chat.py. And so we know that we need to define a class. And so in here, we're going to call this chat. We'll just call it chat. And there's a couple things we're going to need. We're going to need a init here, right? And we're also going to need a start function. We also need to add our remote services, add remote services. So that's another one that we're going to need. So these are our 3 functions. So I'm going to say print init, and then we'll have add remote services. I think there'll be some container stuff for us here soon, soon, James.
So good.
We'll go start, right? And there's something about like def main. What was it? It was how do we do that? It was like main if name main. I'm not a Python person, so I'm doing good. So that's our basic skeleton that we need, right? So we're going to initialize it, we're going to add remote services, and we're going to start. I'm going to go back over to the OPEA example, and we're just going to kind of bring stuff over here one by one. Okay, so I'm going to go over to here, and we're going to go into our GenAI examples. And I need to go back to our chat Q&A in here. And I don't need all this stuff, but let's go take a look at the init first function. Okay, so we're setting ports and stuff like this. All I need is this mega service line. So I'm going to bring that in here, right? And so I'm going to go here, and I'm going to dump that in here, right? We can also define our endpoint. Our endpoint can be whatever we want. So we'll call this James. James is great. That'll be our endpoint. And so those are 2 things that are defined in our class. So we need to bring in this service orchestrator. So I'm going to go to the top here, and we'll just go grab that. And I think it's coming in from here. It's interesting because we're going to really break it down here to make it real easy. But we had to walk through all that stuff. Like otherwise, there was no other way we could do that. So I really just want that one single line. It didn't really paste right. So I'm just going to undo that. I'm just going to write it up manually. Oh, there it is. Perfect. So now we're bringing in the service orchestrator, right? So at this point, the app's not doing a whole lot. We have a service orchestrator, but I'm going to go ahead and just make sure I can start this up, even though it doesn't do anything. So we'll say requirements.txt, and I'll go over to here, and we'll grab these 2 things. OPEA comp should contain fast API, but since fast API is a hard requirement, we're going to include that in here anyway. So we'll go ahead and do that. I'm going to cd into our correct directory here, our mega services, new. I'm going to do a pip install -r requirements.txt. And folks, I'm speed running right now, so don't expect to try to copy this. You're just going to watch and enjoy the speed writing. So go ahead and write this. It's installing OPEA comps and fast API as a library. So now we can reference comps up here. This should do nothing right now, but it should initialize that service orchestrator. So I'm going to go ahead here. I'm going to type in Python app. Python app, or sorry, chat.py. And so it doesn't do anything, but I didn't see it initialize this either. So I'm going to go here and just say print main, because I want to see something, right? And we'll try this again. And it has a slight little problem here. It says unexpected here. I'm missing colons on the end here. There we go. So that should fix our problem. We run this. And so now we have main init add services start. So our template is now set up. We have our initial thing set up. We have no containers whatsoever. This thing could run in a container, and we could containerize this in a moment. And Gloria says, Netflix is no longer necessary. Enough video content for the night. That's funny. So anyway, we have our bare bones set up. So now that we have our orchestrator, we need to have a service endpoint to work with. So we'll go back over to this, and we'll look at the start function. So here's our start function, and it defines this first microservice. I'm going to copy this code here, okay? Because we're really just going to pare this down to the most bare bones thing ever. I'm going to go ahead and paste this in. And so now what we have is our first microservice, which is a mega service. So microservices by default are microservices. But if you want it to act as a mega service, then you set it at this, and it kind of acts a little bit different. It becomes the entry point to the app. And so we can set our host to whatever we want and our port to whatever we want. I'm just going to, oops, I guess I'll set these up here really quickly. So we'll say self.host. And I assume it'd be 0000 for binding. If James, you disagree, tell me. I'm terrible at networking. But
Nope.
I think
that's what I would go for, especially if you're going to be running this in a container.
Oh, and yeah, okay, good. So right now it's not running in a container, but we'll move it there in a second. So we have the host, we have the port, we have our endpoint, right? So we have James is great, 8,000. We can make this whatever we want. If we want to go based on Intel's recommendation, 4 8s for their fun. And so now we have that set up. Notice we have the chat completion request and chat completion response saying the input data, output data. I think what that means is that when it receives an input, it's automatically going to wrap the input into those formats, even though when I use the handle request, I don't ask for that back. So I don't fully understand that. And I don't really care because I have a working example, but I might have a bit of cruft in my code here that could be a bit better. So it's bringing in the service role type, which we need. It's bringing the microservice and chat completion. So that's working really nice. I like how it's doing that for me. And so now we have our microservice and we should be able to hit that endpoint. Will it do anything? No. It should probably error out, but probably what we need is this handle request in. So let's bring that in. So we'll say def handle request. And notice it like here wanted to do chat completion request because it assumes that that's what it wants back. I don't know if this is the case. This is originally what it generated for me, but then it gave us kind of different code. So what's working for me is request. And I'm not specifying this, but it totally could be that. It totally could be that. And this is where I say where I'm just using what works and I need to get more clarification or dig a bit deeper for that. So now we have our handle request, right? And so, yeah, it wants to autocomplete there. So let's go ahead and start this up again. We'll say Python chat. And if we go up here, I expect an error because we're not returning something proper. It says no module name cores, comps cores, mega service, microservice. Okay. So if we go up to here, I think the problem is that it's doing this. So I think we import mega. And then this one's probably fine. But we'll try this again. It doesn't know. It's just kind of guessing, right? So I'm not sure what's happening there, but I'll go take a look at the code here. We'll look at the exact imports. And so the imports here are from comps. So it's top level. So here we can just, instead of doing this, we can just say from comps. This probably has to do with how the init works. I'm not an expert at Python, but I think if we go into here, into the comps, there's probably a init file here, and it's defining what's top level, right? So even though there's subfolders, I think these are what are, not maybe those, but this is the stuff that's being exposed at the top level for comps, so we don't have to drill down. That's my guess. But anyway, so we have the service orchestrator. Go back over here. I'm just looking off screen here, but we have the service orchestrator, and then this thing is actually in comps as well, even though it's in a subfolder. We have this here. And we also have our microservice, which is here. And then this here is kind of right. It's supposed to be import. It is right. I think it's just that if you want to do a multi-line, you do this. I don't know much about imports, but I think this is how you do multi-line. I think we could do that for that as well, but that's okay. So we'll go ahead and run this again. And so now saying request is not defined. And so the trick that I have here is I'm bringing in fast API here. This is actually what this one's doing. And we probably need both of these. Well, we don't need streaming response yet, but we'll go ahead and copy this. Okay, and that's probably why we had to import fast API. If we didn't have this one piece of code here and used it here, we probably wouldn't need to even require fast API because it probably would be acquired another way. So if we go here for a second, down below, I think we now have all of our requirements. So we'll go ahead and we'll hit up, run it again. And so now the app is running. So we can go ahead and hit this on a port. So I'll go to another tab here. I'll just close these other ones so it's less confusing. And I need to write a curl for this, right? So I'm going to cheat. And I'm going to say, I need a curl command to test the mega service for the chat Pi. I have to check to make sure I'm selecting the right one here. Okay. Read the code and make me a curl command. Okay. So I'm doing a little bit cheating here. While that's going here, I'm going to make a new folder called bin. And we're going to call this, we'll call it message because really that's what it is initially. I don't want this to be that, but we'll go ahead and do this. And we'll go up for a second here. I just will tell it to stop. I don't need all that stuff here. And so now we have something here, right? So I'll paste that in. And it's kind of probably pulling from my other code. It is pulling old stuff in here. So like GPT 3.5 is really, really old. And we're not going to use GPT 3.5. I'm probably using Llama 3.21 billion. That's what I like to use. And so we have our data structure here. And this is going to James's great on port 8888. The only thing that's missing here is our shebang. So I'll go up here. And that's not how I like to write my shebangs. We'll go here, and that's what I want. It's only doing this because I have other code. If I didn't have other code in the repo that looked like this, it probably would keep giving me the wrong thing. So now we have our endpoint here. I'm going to go ahead and chmod this, and we'll do a u plus x here. I'm going to say bin. Am I in the right directory? I'm not. So we'll go into the correct directory here, which is the OPEA comps. And then we'll go into mega service new. And in here, we'll do a chmod u plus x bin message. Okay. And so now what we'll do is we'll do bin message. And so we're getting a null. So we're not getting an error, which is good. But if we go back over to here, notice that it received the input. This is actually fast API's format. So it says post James is great. It's returning back a 200. We get back a thing. So now we're kind of in a working state. We haven't added any models yet, but now let's try to add some container stuff. So what I'm going to do, and this is where I might need James' help because I'm terrible at Docker, but we need to make a Docker compose file. I think that's what they're called. Is it .yml or .yaml, or it doesn't matter?
I'm a big fan of spelling out YAML in its completion. So YAML.
The person that created YAML, they say the same thing. Always spell it .yaml. And that's actually how I always do it when even other folks want YML. But like when you see me write CloudFormation, I'll always do .yml because things are more standardized on it, and it's the original recommendation from the project creator.
At one point, yeah, I was looking into the same thing, and I think I came across that same reference that you mentioned.
So what we need here is we need to bring in, like I want to get this running as a container. I want to get us down the path of being containerized right away here. And so I'm looking at the old one here, and we have in here, we go to chat Q&A, we go to Docker Compose. We can run this on Kubernetes. I don't know how to do Kubernetes yet. I'm sure I could figure it out. We'll go to CPU, and we have AIPC Xeon. It doesn't really matter at this point because the difference between these versions is that if you use Xeon, it might choose like the LLMs to be like CPU specific. But right now we're just bringing in the backend server. And so in here, somewhere in here, we have in here chat Q&A Xeon. Notice it's 8888, right? And it has some environment variables. We could set those. I'm just hard coding the variables to keep them really simple right now. But if we were smart, we would probably want to pass environment variables.
Just something in the comments there where it actually says yet another markup language. I actually used to go with that myself, and then someone corrected me, and that's where it used to be apparently, but now it's YAML ain't markup language.
That's what Shazad's saying. For those, I actually have a crash course on YAML somewhere, but I don't know where it is in I have too much content. So here we can see that it's saying OPA chat Q&A tag latest whatever. It's going here, right? And since container name is this, but we'll call this the mega service because it'll be less confusing. And there are these other ones, like when we need them, we'll probably have to define them. But right now, we don't actually have any of these things. Okay, and we have IPC. What's IPC host? Is that like a networking thing or?
Yeah, inter-process communication. So I'm not too sure exactly what that's doing.
Okay, and so the image, would this have to point to a Docker file? Or this would actually be the built image?
So that would be that's the build. Well, it's an image reference, how that's being interpreted. not too sure.
So I'm going to say here, Docker compose the new mega service on this one. How do we reference a local Docker file for the container? And you probably know what it is off the top of your head, but let's see what it produces here. And is it just build? Let's see here. There it is. And we're on write mode right now, so it's injecting it here. I think that's correct. That looks right.
I think it's good. I'm typically not a fan of using this. I usually actually reference the name as you had it before, and I go through the cycle of actually building and using it. But yes, you can actually reference a live and build live on the fly.
Well, I think for now I'll do it this way, or maybe we'll switch it here in a second. But now we need a one to run our container. So I'm going to go see here and see if we can do it. So now we'll say Docker file, and I'm gonna. Well, actually, did I get the right one? We'll say Docker file. This one here. No, that one here, and say I need to run my chat or my chat.py. Can you write my Docker file? Will it write a good Docker file? That's a different story, but it can do something. Should you let LLMs write your own Docker files? I don't know.
I typically always let LLMs write my Docker files now. I mean, you get 90% of the way there most of the time.
But I think the thing is, like, you know what you're looking at, right? So if like you've written a lot before, you know if everything's okay. But like we have this here. So
far, so just looking at this, let's have a look. Yeah, I'm happy with the top line. It's okay. I was initially worried about line 14, but at the time I couldn't see line 5. So you do have a work directory. So it's changing everything to /app. It's copying the requirements.txt into there. We've got our pip install. Yeah, absolutely fine. Copying the rest of the app. So how it looks on your screen now, when you showed it initially, I couldn't see the work directory, and copying everything in would have been bad there.
But I'm assuming I need to move this. Otherwise, if I did copy, wouldn't it bring in everything that I don't want? And so it would be, should it be like this, maybe?
Yeah, sorry. So where's your directory structure? I'm a bit confused.
Oh, it's here on the left-hand side, but this was just in the top-level directory, and I just threw it in an app directory. So I think that we'd want to have this code here, because if we did period, it would then bring in itself into the own thing. And you probably don't need to copy the Docker compose and Docker file into the container itself.
Yeah, for sure.
Like that's like, you shouldn't do that, right?
No.
Like it won't hurt anything, but it'd just be
no. You want to keep that as clean as possible.
Okay.
And
I mean, this is actually external script, so it's make the message script executable. That's not in here, so I think because it was confused at the time, it pulled it in here. Expose the port here to port 8888. We're obviously hard coding things here, but again, trying to keep it really simple. And so this should start up our application. So let's go ahead and I think I can really cheat here. What I can do we have two Docker Compose files? This one, and why do I have two? That's
something you were doing before. Was it Jaeger tracing?
I see. So I'm in this one here, and I think if I right-click it here, if you have the Docker thing installed here, you could do a compose up. You can also just write Docker compose up, which you probably have more flexibility to pass environment variables and other things that you want. And if we go here to the left-hand side tab, see, I was running Jaeger. I wasn't lying. I can kind of do Jaeger. And we have a fail. So it did not work for some reason. Additional property chat Q&A is not defined in the Docker compose new file. So let's make sure that, I didn't even finish writing this. Okay, so this, I'm going to call it mega service. Like this. My file looks a little bit incomplete for some reason. Is there something missing? Services. Right? I think you're supposed to start with services like this.
I think there's, with that now, depending on your your Docker version, it's not necessary to have it.
Oh,
That
really?
on that, yeah, I'm pretty sure. Let me just double check on that.
And while you do that, I'm going to set it to bridge mode. Any suggestions about networking modes?
Let's see what you've got at the moment. Sorry, I'm just looking away.
Right. I have this networking mode here, but why is this arrowing out? Networks, unexpected scalar at the sentence. Maybe it's supposed to be indented. Maybe it's supposed to be indented. There we go. And we'll do.
Oh no, it's just sorry. So it's the version line which you don't actually need anymore. Was I was
Oh,
referring to. So you typically would see the version line at the top, but yeah, you haven't got a services line there, have you?
I do have services, but I don't specify a version. Our Docker file messed up because we're trying to copy the requirements here. Copy the requirements first to leverage the Docker cache. Okay. So this would be requirements. Wouldn't it be the other way around?
Now, in terms of the networks, I normally just go with a name network rather than specifying, but that is a bridge by default.
Mm-hmm.
So I typically, when I'm doing this, I don't actually put that in there. I will give it a named network. That's all.
It might have looked like it worked there a second ago, but it didn't. I launched up the wrong one because I have that other one here. So I'll go back over to this one. This is the one we're actually working with. I'm going to try compose up again. And so you're saying like you would name the network?
Yeah. So the essentially you could put networks : then underneath put exampro.io. Is that your domain? What's your domain for exampro?
.co.
Yeah. Exampro.co, and then under that put name : exampro.co.
And so when we're doing networking, then we, instead of doing we can then reference that host or that name within our services so that it's
So you can end up with something nice here. So as we're composed as its auto DNS, so to speak, you can actually have this as web.exampro.co, database.exampro.co. I normally don't put the bridge entry on there. I think it's assumed by default.
I see. So we are getting some errors here because it's already in use, I believe. And so I'm going to need to kill something on port 888. Oh, it's because it was running over here. That's why I was running it manually. So we'll go ahead and we will compose up again. And we'll see if we get this working. And did it fail? Error response from daemon network not found. We have a networking issue.
Scroll back up a second, that output.
Oh, we got to create the network. Oh, this is where we actually have to do networking stuff.
No, normally you don't. I mean, normally we compose.
Do you think because I'm running WSL that could be an issue?
No. But the network is saying about there is mega service new. Hang on.
Well, James, we're out of time. So what I'm going to do is I'm just going to set it back to default for now. I'm going to figure out how to do the network thing. But now that you're talking about it, I remember us doing this in the AWS Cloud Project Bootcamp. So it's starting to come back to me. So I have to go back and watch some of our videos because I remember doing all these little things and all these recommendations. I'm going to go ahead and just see if this starts up. And all I want to see if I can just ping it, right? So if it builds here, it does not still have an error, even when I switch it back to this. Interesting. What if I just take the networks out completely? Interesting. Okay. Well, I clearly have some kind of problem with my machine. We are out of time, but this will be something that well, it seems like it's specific to my machine. But anyway, sorry?
Just as a very quick one, if you were to do a Docker network ls,
Sure.
I wonder if we can. What is there? I wonder if, as I believe with this, that the compose should self-manage. So possibly you might be able to remove the network from there, and then when you run the compose again, it would be okay.
So
But that would be it would be a Docker network subcommand if you were to do Docker network help.
Help?
Which scroll back up. Which one was it actually saying didn't exist? So if you scroll back up, what was the? It was A6A. Scroll back down.
A6A. Would it be in the Docker Compose file where it was saying that?
No, yes, something isn't right here. It's you can see it's actually creating that, but then it's saying you could try just removing the existing one which exists there. So yeah, remove that mega service default. So Docker network, yeah, try that.
That's my guess. I remember Docker being very pretty standardized for their API.
And now if we do the ls, okay, and now if we try it again.
We'll go here, do Docker Compose up. Still get that error. It does create it, which is unusual, but then we get a daemon response error, which is unusual. Just other standard Docker PS? Is there anything else running here? No, nothing's running. But James, we are out of time. Just as we start getting the meat, James is like, for those who don't know, like James will just keep going and going. Like he'll give me like super production. Well, like if we had more time, we'd have like the most super production thing, I think, in an hour or two.
I've been sneaking off camera a couple of times to eat a sandwich, but yeah, I keep going.
Oh, you're like me. See what I do is like 5 or 10 minutes in between takes, I shove my mouth full of food. But you literally during things, you just pause, go shove food, and then continue. That's dedication. Folks, we have office hours Q&A, or sorry, after class. I said office hours. After class Q&A in the Discord for those who want to come over there and join us in the after class Discord and ask questions. You absolutely can. James, if you want to come on over, you can as well. If you want to go eat, you can go eat too as well and see the rest of your day. Appreciate you coming out here and getting us through some of this container stuff. I ate up all the time with my big diagram, unfortunately.
Well, we can sync up as well, and we can actually work on some bits on this offline.
James, I will take everything and anything you.
Yeah, this is really interesting, and I to be honest, I don't think we would have, even with half hour or so at this, I don't think we would have done it justice. So let's actually do that, and let's tune it in, comment the actual Docker Compose file, and have it there as a reference for everyone.
And for folks, I actually mostly was chopping wood, but we solved the problem. So I have a gas furnace or oil furnace, and I kept saying back, I was like, I'm getting lightheaded because of the fumes. And he said, oh, you know what I can do? I can stop bleeding onto the ground. I was like, what? Like, I just bleed on the ground. So maybe it's just like picking up and doing that. So now we put a little drip cup. And so I don't have to cut as much wood, and I can. There's no chance of me fainting during live stream.
Well, we had a good chat, didn't we, about the radiator loops in the UK? Is that something you're now going to do yourself?
I'm thinking about it. For those who don't know, or for those that actually are in the UK, I guess they have heated towel racks in their places, but in Canada we don't have such fancy systems, right? But I know that like this video will be dated because I'll mention this, but I know that the KubeCon London is coming up. For those who can't afford tickets, does KubeCon London ever do like free events around the area? Like, do people ever meet up on the outskirts of it?
Yeah, so there's lots of things that go on. So there's a very good scholarship program with the CNCF. So I recommend many people for any kind of KubeCon, if you fall into that category, do apply, because they are very generous. You actually get you can have accommodation, you can have the ticket, you can have the travel covered for free. Outside of that, there's various ones. Probably the biggest one is an event called Rejects. And Rejects is where essentially if you've submitted to KubeCon and you didn't get into KubeCon, you were rejected. These were the ones which actually get picked. And it's a lovely event. You get lots of people.
Is that a free event outside of the conference or near it?
Yep, it's a pre-event. It used to be one where you had to buy tickets for it, but the tickets were like $50. Now it's a free event, or it has been the last time, because of sponsorship. So yeah, come along to Rejects if you're in London. I'm going to go to Rejects. We can hang out. It'll be good.
So there you go, boot campers. If you print out your CNCF landscapes, and James will sign it for you. Okay,
you're walking around with a massive.
But yeah, again, that's just a way to connect, because I know some of our folks here are in London, and so that might be an opportunity for them to meet the James Spurin. But anyway, thank you for helping us out so far. Boot campers, I'm going to go see you in the afterclass Q&A Discord right now. And of course, it's time to cue the bootcamp song, but we'll see you in class soon. Ciao, ciao.
Thanks, everyone.
In the lounge, your math up starts. Hints from those shared design. Sand wax the last of my wars. These found through causally flying. And spam the whims and down our parts. Bees one that ever allowed alien friends from distant sounds. Share joy of the luck we brought. Amid the hum of machines, the glance reveals two souls connecting in the cosmic wheels. A tree forged over flavorless intertwines. Universe butterflies like the fires. Together we sway, stars in our eyes. Across galaxies wide, no halting skies. Left the echo in the empty aisles. Eclipse but sheds in a million losing right across the universe of sky. Will your sandwich could suffice to break the barriers now the ice? Once tossed our eyes, that's often by its smile. Cosmic gently fades for just a little while. Under flickering lights in this humble place, our mighty probes transcend the time and space. In its lunge of not what was the light, our mouths like evils we still side by side. From beyond the stars we both come to fall in peace within the hum and the hum. Eclipsed by shadow moons and right across the union dazzled sky. For you it's some which could suffice to break the barriers, melt the odds.